For your controlled assessment in geography, you've been on a field trip and you've collected some data. And some of that data has been about the steepness of parts of valleys. Now, as part of your controlled assessment, you're going to be asked to calculate the gradient of those slopes, and we're going to show you how to do that. So here's a picture that might help you, if you can visualise this. This is the slope of the side of part of a valley, and this point here would be where you'd put your ranging pole. This would be where you put your second one. You put those 10 metres apart, and so this side here represents those 10 metres. You'd then stand at the bottom here by the first ranging pole, and you would look up through your clinometer and see how much you would have to turn it, so the steepness. So here, this would represent the angle that you've got through your clinometer, and this side here would represent your 10 metres. Again, I've got another example here. This is another part of a valley. This is the middle course. So again, it goes around two sides. You could put a ranging pole here. You could then walk up 10 metres and put another one here. So you've got a distance here of 10 metres, which is this side of the triangle. And then this would be your angle of elevation, which is what you would see when you look through your clinometer when you look up. Now, in order to find the gradient, you're going to have to find this height here and this horizontal distance here, which is why we're going to use right angle triangles for this, and we're going to have to use trigonometry. So, in order to do that, we're going to first have to look at how we're going to label the triangles. So, these two triangles here could represent parts of your valley. So, this could be one sloping this way, this could be sloping this way. So, this is always going to be the angle that you see when you look through your clinometer. And we're going to base all our labelling around this angle. So, the first thing you're going to label is this side here. Now, this is the easiest one to label because it's the longest one and it's opposite the right angle. And this is called the hypotenuse. So we label that H. Next, we've got, again, starting from where you're looking, we've got the one that is opposite to the angle. So if you imagine this like an eye looking across, this side is looking at this side, so it's opposite to this side. So we call that O. And this is the last one. You always label this one last, it's the trickiest one. This is the adjacent. Now, adjacent means next to, so it's next to the angle, but it's not the hypotenuse. If we were looking at the valley on this side, we'd be looking through the clinometer over here. Again, this would be the longest side, if this is a right angle triangle, and it's always opposite the right angle, so this is the hypotenuse, so we call that H. This is the one that we're looking at, so if we've got an angle, we're looking over here. This would be the opposite side, because it's opposite to the angle. And the last one is the adjacent, so it's next to the angle, but it's not the hypotenuse. Now, the reason we've labelled this is because we need to look at some trigonometric equations. So, we need Sohcahtoa. You may have seen this before. This is just a way of remembering the different ratios, and it splits into three parts. So this one here represents the sine ratio, and we can only use the sine one when we've got the opposite and the hypotenuse, or we've got one of them and we're trying to find the opposite one, or the other one, sorry. So if we have the opposite and we want to find the hypotenuse, or we've got the hypotenuse and we want to find the opposite, we're working with O and H, so we're going to use so. And this gives me sine of the angle is equal to the opposite side divided by the hypotenuse. So it's a little formula we're going to use, a little equation, to be able to solve the problem. If we've got the adjacent and the hypotenuse, so they're the two pieces of information that I've got, or the ones that I'm working with, then we're going to use ca, which is the cosine equation. So cos of the angle is equal to the adjacent side divided by the hypotenuse. So again, you would just put the numbers that you've got into that formula. Now, the last one, which is actually one that you don't need to use for this part of your assessment, is the tangent equation for TOA, which is the tangent, or tan of the angle, is equal to the opposite side divided by the adjacent. So this would work with the opposite and the adjacent, but again, we're not going to use those. So let's look at an example. So, you've gone and measured some data. You've set your ranging poles so that they're 10 metres apart, and you've measured the angle of elevation using your clinometer as 18 degrees, and you're asked to find the gradient. So, in order to find the gradient, you need to know the height and the horizontal, and we're going to work those out using trigonometry. So, you always label it first. So you're told that the distance between the ranging poles, so if you imagine that they're here, distance between those is 10 metres. Okay, and you're told that your angle, you've looked from here, is 18 degrees. Now we use this angle to label the triangle. So this side here is the one we're going to label first because it's opposite the right angle and it's the longest one, so that's the hypotenuse. And the one that the angle is looking at, so the one that it's looking over, the one that it's opposite to is the opposite, so this one's O. And the last one is the adjacent, so that's the one that's next to it, but not the hypotenuse. Now the first thing we're going to look at is finding the height. Now, we're going to have to look at Sohcahtoa. So, if we write these out, we need to go through which piece of information we've got and which ones we want to work out. So we've got the angle, we've got the hypotenuse, and we want to work out the opposite. So we need the opposite, and we've got the hypotenuse, so we're working with O and H. So if we go back to our little formula here, or a little mnemonic, we are going to be using SO. And SO represents sine of the angle is equal to the opposite side divided by the hypotenuse. So now we're going to put our numbers in. So the angle is 18, so we put sine of the angle, so sine 18 is equal to the opposite side, which we don't know, but this is the height, we'll call it the height. And we're going to divide that by the hypotenuse, which is 10. Now at the moment we want to work out the height, but it's been divided by 10. The opposite of divided by 10 is times in by 10, we're multiplying. So we're going to do the same to both sides to undo it. That undoes this division, which gets height on its own, which is what we want. But if we do this by 10 as well, we've got times by 10, so this gives me 10 times sine 18. And we should be able to type that straight into our calculator. Now be careful, calculators work in different ways. I've got a Casio here. Quite a few of you have Casios. The newer Texits work like this, but there are some that work the other way around. So if you're not sure about your calculator, then you might want to have a talk with either one of your geography teachers or your maths teacher. Now, you need to make sure that you've got D or DEG in the display at the top. Hopefully you can see that. If it says R or G, it's in the wrong setting and this will not work. So you need to make sure that you've got that at the top. If you, again, you're not sure about how to change that, come and see one of your maths teachers and we'll show you how to change it because you need it for maths as well. So now, in my Casio, I'm just going to type this in. So 10 times sine 18, so 10 times sine 18, and I get 3.09 something. Now, we need to write this out properly. So the height is 3.090169944. Now, that may seem a bit long. We can round it to 2 decimal places here. But when we come to doing a further calculation later, you must use this full number, or at least 4 or 5 decimal places, because otherwise you'll get rounding errors. Okay? So we've worked out the height. We now want to work out the horizontal. So the horizontal is this side here. So we want to work out A, and we've got H. So if we've got A and H, we go back to Sohcahtoa, and we look at which one involves A and H, and it's this one here. So C represents cos, or the cosine equation. So cos of the angle is equal to the adjacent divided by the hypotenuse. So now we're going to go back to our question and we're going to substitute those in. So the angle we've got is 18, so cos 18 equals the adjacent, which we don't know, but this is our horizontal. And we're going to divide that by the hypotenuse, which again is 10. So this looks an awful lot like the last one, except instead of sine we've got cos. Again, we've been divided by 10, so we want to undo that by times it by 10. So we do that to both sides. That cancels out this dividing. And we're going to do the same to this side, so this is now 10 times cos 18. Now again, as long as your calculator is in degrees, we can type this in. So we've got 10 times cos 18, and we're going to write all that down. Okay. So again, I might round it here for just neatness, but when we come to the calculation we're not going to round it. So now we found the height and we found the horizontal. That's the tricky bit. Okay. Now, in order to find the gradient, you're talking about the steepness of something. So you're saying how much it goes across by how much it goes up. So you may have come across this before, especially if you were doing gradients of graphs. To calculate the gradient of something, you do the change in the vertical. You may have heard of it as change in the y direction. So change in the vertical direction divided by the change in the horizontal. So all we do now is we work out what our vertical one was, so that's our height. So this is 3.090169944 divided by our horizontal distance, which is 9.510565163. Seems a bit tedious, but it stops us getting rounding errors. Now you could use the answer button here if you know how to use it. But so this here is my previous answer. So 3.090169944 divided by, and we can just press the answer button because it saves this number in here. And you're going to get 0.32491969 something. And at this stage we can round it because we're not going to do any further work with it. So the gradient for that slope there is 0.32. Now if you wanted to compare this with another part of your valley, we could look at another one, and hopefully we'll do this one a little bit quicker. So again, we've got a distance between our radiant poles is 10 metres. The angle this time is 12.5. We're going to label our sides, so this would be the hypotenuse, the opposite and the adjacent. We're going to work out the height, and we need to look at Sohcahtoa. If we want the height, that's this side here, so it's the opposite. We've been given the hypotenuse, so we're going to use O and H again, so that's sine. So sine of the angle equals the opposite, which is the height, divided by the hypotenuse, which is 10. You need to rearrange this so you get the height on its own. So you want to get rid of this 10 on the bottom, so divided by 10, the opposite is times it by 10. So you're going to end up with 10 times, oh I forgot to put in here, sorry, your angle was 12.5, I'm trying to rush a little bit. Okay, so 10 times sine 12.5 equals the height, and then you can work that out. So 10 times sine 12.5 equals, you can still see that, 2.164396139, and again I'll round it here for the moment, but we will use this calculation, this number for the calculation. Then I want the horizontal. So again, the horizontal is this one here, so this is A. This is the one we were given, which is H, so we've got A and H, so we're looking at cosine, and cos of the angle equals the adjacent divided by the hypotenuse. Put the numbers we've got in, so the angle is 12.5, the adjacent is the horizontal, which we don't know what it is. We divide that by the hypotenuse, which is still 10. Rearrange that by times it by 10 on both sides. So you're going to get 10 times cos 12.5, and that will work out the horizontal. So you should see a bit of a pattern emerging. If I type that into my calculator, okay, 10 times cos 12.5, and we get 9.7629600071. So I'll round it for the moment. Okay, time to get the gradient. So the gradient change in vertical change in height divided by change in horizontal. And again, you just type these into your calculator. So the vertical, which is the height, is 2.164396139, and we divide that by 9.7629600071. So on my calculator, I'm going to type in 2.164396139 divided by, and I'm going to press the answer button again, or you could just type this number in, and I get 0.221694 something, which we can now round because that's the end of our calculation. So, if we were now comparing these, we've got two answers. We found the gradient for the first one, which was 0.32. We found the gradient for the second one, so we could say this was maybe the middle course and the upper course. So now if you were going to compare them, you would say that this one here has a gradient of 0.32, which is steeper than the gradient of this one here, because that's a smaller number of 0.22.